Okay, so let's start with a truly wild idea. What if our universe, at its absolute most fundamental level, isn't governed by these abstract, invisible fields, but is actually a giant mechanical system? Today, we're going to dive into a source document that puts forward this exact, pretty radical idea. You know, for over a century, we've had this picture of space-time as this smooth, continuous, rubbery fabric. But what if that's just, well, an illusion? This theory kicks off by asking a really profound question. What if reality is actually pixelated, made of these unimaginably tiny, discrete grains? And this really frames two totally different ways of looking at everything. On one side, you have the classic view, this seamless reality where everything is described by abstract fields. But on the other, you have this new granular idea, where literally everything we experience, gravity, light, matter itself, it all just emerges from simple, local, mechanical interactions. Forget fields, think physical pushing, twisting, and pulling. And look, this isn't just a neat little thought experiment. This is a serious attempt to solve the biggest puzzle in physics today, finally bridging that gap between the smooth world of Einstein's gravity and the bizarre, jumpy world of quantum mechanics. So, let's dig in. Let's explore the core idea of this universe made of grains. Here it is, the foundational rule, the one big axiom this whole thing is built on. The theory says space-time is just a dense packing of what it calls Planck grains. Now, what that really means is there are no separate forces or fields acting at a distance. Nope. Everything is just the result of these tiny grains interacting with their immediate neighbors. It completely replaces abstract fields with pure, simple mechanics. All right, so if everything is just grains interacting, what kind of interactions are we even talking about? Well, that brings us to the four basic strains. These are the fundamental movements that, believe it or not, build our entire physical reality. And this is where you start to see how incredible complexity can come from mind-bending simplicity. According to the theory, when these grains are squeezed together, what do we get? We get gravity. When they twist against each other, boom, that's electromagnetism. Even the state of space-time itself, whether it's acting like a solid or fluid, that just depends on how tightly the grains are packed. It's an entire toolkit for physics built from just four simple mechanical properties. It's wild. So now we get to the engine of the whole system. How does the universe decide what to do based on all these strains? It all boils down to one simple question. Does space-time bend or does it break? Now, don't worry about the math here. Seriously, the point of this equation is actually pretty simple. It's a rule book. At every single point in space, for every single instant in time, this formula acts like a little calculator. It just adds up all the different stresses, the squeezing, the shearing, the twisting, and it calculates one single number, the total energy that's stored in that tiny patch of spacetime. And this is the absolute heart of the theory, a cosmic if-then statement. The universe is constantly calculating the local stress and comparing it to some critical limit. So, if the stress is below that limit, space-time behaves elastically. It bends, it warps, it snaps back, just like Einstein predicted. That's our familiar, classical world. But if the stress goes above that limit, the system fails. The grains literally slip and rearrange themselves. And this failure event, it's not a catastrophe. The theory claims that's what a quantum event is. It's one single rule that gives us both classical physics and quantum physics. It's a beautiful idea, right? So elegant. But a theory in physics is only as good as its predictions. So the big question is, does this mechanical model actually match the reality we can go out and measure? Let's check the numbers. And this is where the theory gets really, really compelling. This table shows some of the fundamental constants of our universe. Now, that prediction column, those values are calculated purely from the geometry and mechanics of this granular model. There are no external inputs, no fudging the numbers. Now look at those error margins. They are astonishingly small. These aren't just lucky guesses. These are results that fall directly out of the theory's core principles. Let's just focus on one of these for a second, just to let it sink in. This model predicts the mass of a particle called the muon with an error of just 0.28%. I mean, that is just remarkable accuracy for a theory that starts with such simple mechanical assumptions. It really suggests there's something very real about this way of thinking. Okay, so let's step back and think about the really profound implications here. If this model holds up, if it's even close to being right, what does that mean for our understanding of reality itself? Well, what this gives us is a single, unified framework. In its elastic mode, it gives us the smooth world of classical physics we see every day. Check. In its failure mode, it describes the jumpy, weird world of quantum mechanics. Check. And on top of all that, its very structure predicts the fundamental constants of our universe. It connects everything under one mechanical roof. The source material leaves us with this incredibly powerful and definitive statement that kind of turns a century of physics on its head. It says, this is not an approximation of a field theory. It is the mechanical reality which field theory approximates. In other words, our current understanding isn't the real thing. It's just a shadow of a deeper mechanical universe. And that leaves us with one final, absolutely mind-bending question. This theory might describe the behavior of the machine perfectly, but it forces us to wonder, if our reality really is just a machine, what are the gears made of? And that's a question that pushes us right to the very boundaries of physics itself. Thanks for exploring it with me.